Sketch the graph of the function f that satisfies the following conditions. The conditions are listed over here on the left. What's new about this graph that may not have been new before are these conditions down here, these last four conditions dealing with the derivatives. Before we get to that, I want to plot all of these other conditions up here. So the first thing I see is that the vertical asymptotes happen at x equals 3 and negative 3 and x equals positive 5. So I'm going to put the vertical asymptotes in at negative 3 and positive 5. The next attribute I see is that the horizontal asymptote is y equals 4. So I'm going to put a horizontal asymptote in there. The horizontal asymptote gets crossed at x equals negative 2.5. That point is right here on the graph, negative 2.5 comma 4. The graph is smooth. That's the next bullet here. That just means there are no cusps or sharp turns in this graph. Another way to think about it is that between these two vertical asymptotes and outside of these two vertical asymptotes, the graph is differentiable. It's just not differentiable at these vertical asymptotes. The x and y intercepts. So the x-intercept is here at negative 2. There's another x-intercept over here at positive 4. And there's a y-intercept at positive 1.4, which is about right there. So all of this information is over there on the graph in red. Now down here at the bottom, I'm going to section off the graph in blue based on the first derivative intervals over here. So we can find out where this graph is increasing or decreasing. So one thing to remember is that if the first derivative is positive, that means f is increasing, the original function. So over here on the graph at the bottom, I'm going to section this off at negative 3. So I'm going to put a little line like this. I'm also going to section it off at negative 2 because that is one of our interval breakers over here. So I'll do that, negative 2. And I need to also section this bottom portion off at positive 1 and positive 5. So I'm going to be here at positive 1 and positive 5. So what this information over here tells us is that on the interval negative infinity to negative 3, the graph is increasing. And on the interval from negative 2 to 1, the graph is also increasing. And with this second bullet with the first derivative, all these other intervals, the function is decreasing. So I know in here that function is decreasing, decreasing, decreasing. All right, let's see. If the function is increasing to the left of negative 3, and for some reason you thought you should start underneath the horizontal asymptote, since it says that you have to keep increasing, at some point you will have to cross the horizontal asymptote. But over here, the only place we cross the horizontal asymptote is when x equals negative 2.5. So we cannot start underneath this horizontal asymptote anywhere, otherwise we will have to cross it. So we will have to start above the horizontal asymptote and keep increasing. As we start to the right of this vertical asymptote, or the interval in between these two vertical asymptotes, we know that the function is decreasing between the vertical asymptote negative 3 and this y-intercept negative 2. So that means the graph has to start up here and decrease until we get to x equals -2. And then from there, it increases until x equals 1. So even though we've got a y-intercept here at 0, 1.4, we need to keep increasing past that all the way over until the x value 1. So maybe we can increase until there. Increase, increase, increase. And then once we hit that value, if you look straight down, when x equals 1, we need to start decreasing again. And in fact, we need to decrease all the way over until x equals 5. So the graph should be decreasing like this. And then lastly, to the right of this vertical asymptote, you will always be decreasing. So we can start as high up as we can, as it is a vertical asymptote. But again, we know that you have to level out at this horizontal asymptote. Otherwise, the graph will cross the horizontal asymptote again, and you cannot do that. The only place it crosses is right over here again at x equals -2.5. So let's get rid of that and go back and draw in our graph. Since it's decreasing, we have to start above the horizontal asymptote, and it'll start decreasing and level out at the horizontal asymptote. Now let's double check here that this makes sense with our second derivative notation. We know that the second derivative tells us the concavity of the original function. And if the second derivative is positive, then the original function is concave up. So between -infinity and -3, this portion of the graph here, this blue graph, that is looking pretty concave up. So it looks like just by reasoning through our first derivative, we were able to get that portion was concave up and increasing. The next interval here, -3 to -1, we also needed to make sure that this graph is looking concave up. And if you follow this graph from -3 to right here, -1, it looks like just this portion is opening up. So again, we were able to get concave up just by reasoning through our first derivative intervals. Then at 1 and all the way over until 5, it looks like this graph is concave down. It is now opening down. And if you look over on the left at the second to last bullet, the second derivative is negative, means the original function is concave down on that interval -1 to 5. All right. And then lastly, to the right of 5, from 5 to infinity, the graph is back to being concave up. And yes, this graph is concave up. Even though it's decreasing this time, it is definitely opening up. The last thing we need to do here is label the point of inflection, and that is right here on the graph with the black dot. This is my POI, and that is because if you come back over here to the concavity between -3 and 1 is positive, or concave up, and at -1, the concavity changed to being concave down. And that is a point of inflection because I can put my laser pointer here and give it an x and y coordinate. You may notice that at x equals 5, the graph stops being concave down and starts being concave up. However, there is no point of inflection here because this concavity change happens at a vertical asymptote. So this blue graph over here is what the sketch of the graph that satisfies all these conditions looks like.